All right, I think we've gathered enough people for us to be able to get started. Just in time too, because it's now 5 past. All right, so before I get on with the actual content for this week, I just want to quickly highlight something. So finally, the assignment to spec sheet is now available on the assessments tab in Milo. So if you have a look in the assignments page, you should be able to see assessment task 2 with both the AR and VR spec sheet available. Now, make sure that you guys are having a look at the VR PDF one, because remember, you're doing the VR module for like this particular module, so you have to produce a VR prototype as a result. For some reason, some students are still kind of a bit confused with what they need to produce for assignment 2. So, like, let me take this moment to say that yes, you are going to need to make a VR prototype. Now, I just quickly loaded up the assignment spec sheet here. So pretty much the main thing that you have to deliver or submit is the VR prototype itself. So like a build of your Unity project. I'll actually talk about what you need to do next week in regards to that. But basically, you've already covered the process of how to make a standalone build back in the Creator Kit FPS project. But I'll just do a quick review of that process so that everyone has like a sort of refresher of how it works. And in addition to the build, you'll also have to make like a 1,000-word report. Now, what needs to be contained in that report is already found in the last page. So Wing's actually gone ahead and improved the sort of like the format of what we're actually looking for in your written report. So you've got the multiple sections and also what each of the sections will contain. And the good thing about this as well is that if you aren't really clear as to like the sort of descriptions in the subsections, so say for example, what are the significances of your application in the context of your chosen scenario section, you can refer to the slides that are actually linked inside this spec sheet, which is really nice for your reference. So make sure you have a look at that format for your written report. Now, what's changed with this assignment compared to last semester is that Wing is actually providing you 3 different project scenarios this time. Each scenario will have their own context as well as user requirements. Those user requirements will also highlight a specific problem or limitation. And basically, the main idea is that the VR application or prototype that you're creating for that particular context will need to address that problem. So you're using the VR tech available in order to sort of like find a workaround to whatever limitation is actually being listed here. So you've got 3 scenarios. You only need to pick one. So you have either a museum sort of scenario. You've got the design of the new UTAS campus. So this is like a architecture visualization sort of scenario. And then you've also got the fear or phobia. So this is more like sort of like a therapy kind of thing where you just try to provide your user with like a sort of safe environment for them to work out, their fears, or try to sort of like address, like how they would deal with those irrational fears. So, but yeah, so have a look at that. Probably before you move on to figuring out or sort of solidifying, the sort of application idea that you have for the assignment. And also, if you've noticed, Wingy's pushed back the due date from Monday to Friday. So now the assignment is due on the 28th of August at 5 p.m. So hopefully that should make up for the delay of like the release for the assignment specs, which is really good. Hopefully that should ease up some of the pressure for you guys. All right. So just a quick recap of where we're supposed to be at for our Unity project for our VR prototype. So last week we created this basic setup where we had a scene with an FPS controller object on it. So that FPS controller object is the avatar that you're going to be controlling with your mouse and keyboard. Now, if you're already messing around with VR hardware, like if you have access to it already, you might have used one of the camera setup prefabs. So like either OVR camera rig or OVR player controller. That's completely fine as well. And also, you might have gotten like a few art assets from the asset store as well. So you've imported a couple and probably put that down in your scene and then arranged them in some sort of composition to make up like a small part of your virtual environment. Now you may have to adjust that now based on the sort of like context that, scenarios that Windows provided for you. But hopefully that shouldn't set you back up a bit. And you can sort of adapt your current idea to address the scenarios listed in the assignment spec sheets. All right, so that should be what our project would look like. And now we're actually going to look into implementing a basic interaction for your application. And then once that's done, you can start thinking about how to improve that interaction, or you can branch out to thinking about the other interactions that you need to put in your prototype. Now, I'm going to do things a bit differently this time around for this session. So what I'm going to do is I'm actually going to do like the live demo for the interaction implementation at the same time while I'm going through these slides. And I just want to do that so that I sort of minimize the amount of time that I take every time I start talking at the start of these sessions, which I'm sure you'll agree I've been taking up quite a bit of time. So yeah. Anyway, so for interactions, generally when we want to implement like an active interaction between the user and the application itself, we need to be able to do two things. So first things first, we need to actually be able to detect if the user is giving input to the application. So whether that's like a button press from a keyboard or mouse, or user sort of reaching like a specific point in your virtual environment or interacting with a specific object, as long as it's like some sort of input that the application has to be able to react to, then we need to figure out a way to sort of set that system up. And then once we are able to have that sort of system going, next thing that we need to worry about is we need to be able to call component methods and change component properties that we actually need to change based on that given user input. So remember that I said before, game objects by themselves don't do anything. It's the components that are attached to them. So that's stuff like the transform or the audio source or the colliders and whatnot. They're the ones that actually define how the game object behaves, or sort of like, what kind of functions that game object will actually deliver when your application is running. Now, again, we'll be using scripts to accomplish those 2 points. And the way I've done it for this one is that I've actually provided like really small code snippets that you can copy and paste. Well, not copy and paste, but sort of copy to your own custom scripts, and then write your own piece of code in to actually specify, what you want to actually happen when this specific scenario turns up. Now, what I've gone ahead and done for the live demo is I've loaded up this basic project here, as you can see on the screen. So right now I've just got, like a simple scene with like a plain floor. I've got a couple of barrels that I downloaded from the asset store because I just wanted props in there for some reason. I've also got this neat little radio object sitting on top of one of these barrels. And of course, I've got the FPS controller avatar game object at the center of the environment, which is what we need to actually start roaming around. And now what I want to do for this demo is that I actually want to implement an interaction between the avatar and the radio. So if the user clicks on the radio object with their mouse, so they're having a roam around. So they're having a roam around, and if, say, they stand in front of the radio, and if they decide to click their left mouse button while looking at the radio game object, I actually want the radio to play like some kind of audio, so like music or something. So that's what we're going to look into implementing. Now, emphasis, by the way, on the active interaction part. So the main requirement for your assignment too is you need to have at least one active interaction. So when we say active, it's basically like an exchange between the user and the application where the user initiates that particular action. So again, if the user presses a button on the keyboard, for example, and maybe say something in your application again, does a crazy animation or plays audio or changes color or something, like as long as the application reacts to that action from the user, then that counts as an active interaction. Now, you might think, based on that description, that even just moving around your avatar is an active interaction because you're pressing a button on your keyboard to actually move your avatar around. Now, in that case, you are definitely correct. But WinU is looking for an interaction more than that. So you can't just put in like an avatar in your environment and call it a day with active interaction. You need to add in at least one more, and that other interaction should actually mesh with what you're trying to accomplish with your prototype. So again, that's where the project scenario and the context comes in, along with the limitations that you need to address with that particular context. All right, so real quick, if the scripts that we'll be needing to make are actually counted as asset files. So if you want to create scripts in your project, all you need to do is you need to go to the project view at the bottom of your editor interface, as shown here in the screenshot. Basically, just right-click on any empty portion of the window, and then that should bring up this menu here on the right. So you just go ahead and select Create, and then that should bring up this right-hand menu here, and you can go ahead and select C# script as the new asset that you want to create. So remember that we're using C# as our programming language for our scripts. If you don't have any experience with C#, but you've used other programming languages, then there isn't really anything to worry about, because really all you have to deal with is the difference in syntax and formatting between your main programming language and C#. And honestly, with the kind of basic stuff that we're doing for our prototypes, it shouldn't really be that big of a deal. Now, of course, ideally, your script name tells you what it actually does. I'm not just saying this as to sort of encourage you to build up a good habit when you're creating, assets or organizing your project, file structure. Also, when I'm helping you troubleshooting with your scripts, so like you have multiple scripts set up to manage just one interaction in your application. Usually it saves me a lot of time if I can tell at a glance, just looking at your script names, what that script will actually do. Because sometimes like errors will need to be traced between the different scripts. And just having that extra time saved just adds up a lot, especially when I'm having to like help deal with like problems from multiple students. So, just a quick reminder there to sort of like help optimize the troubleshooting process between us, especially since it's a bit more time consuming doing it online. So, for example, if you're creating a script that plays audio when the application detects a mouse click from the user, kind of like what we're doing now, maybe name it something like play audio on mouse click, just an idea. But as long as it's descriptive, it doesn't really matter too much about the exact naming. Now, once you've created the script, you will actually need to attach that script to the game object as well. So all the code or instructions written inside your script won't actually work until you attach it to a game object that's present in the scene. So doing that is fairly simple. It's just a matter of selecting the game object from the hierarchy window. So in this screenshot here, for example, you're just selecting the cube, and then it's dragging the dragging the script asset from the project view from down below, and then dragging it to the inspector window on the right, as indicated by this direction of the arrow here. And once you've done that correctly, so you let go of the mouse button, you'll know you've done it correctly because you can see the script. So in our case, it's do something on button press. So it's going to be listed as a component that's attached to that game object. So fairly simple. Do we need to do some coding in the assignment? You definitely have to do some coding, because otherwise you won't be able to set up interactions in your app at all. and that's why I'm doing this sort of quick introduction to the code snippet thing. Like there are resources in the web page that I'm going to show later. If you're really nervous about that, so like there are some videos that you can use as reference, and I'm going to be going through the process as well. So hopefully that should give you like a nice sort of primer on how the workflow just looks. Right. So just to quickly recap, so we want this radio to play music. When the application actually detects a mouse click over the radio object when we're looking in front of it. Now, before we even get into any sort of scripting, we need to make sure that the components that we need to use are actually attached to the game objects. So first thing that we should probably do is we should probably attach the audio source component to this radio game object here. So what I'm just going to do is I'm just going to select the game object here on the hierarchy window on the left. And then on the inspector window on the right, I'm just going to go and click add component. And the exact component that I need here is called audio source. So, oh, not that one. Bloody autocorrect, there you go. So audio source is basically this component here where you can assign a music file in the audio clip property. And then once that's assigned, you can actually create a script that calls the play method from this audio source in order to actually play that audio file given like a specific condition. So say, for example, that button, that mouse click that we were talking about earlier. So before we call this finish, we need to link a music file here in the audio clip property under audio source. Now I've gone ahead and imported some random MP3 file that I had in my machine lying around. So it's this one right here, Blackest Luxury Car. Again, just some random music. All MP3 files should be, you should be able to import into your Unity project, which is fine. All right. So again, while having your radio object selected, we just need to drag this MP3 file from the project view and then drag that on top of the audio clip property box to assign it like so. And you know you've done it correctly because the property box now lists your MP3 file as the audio clip for the component. And that's all we need to do for now. So let's go back to the slides. Now, if you're using an FPS controller, which means that you're using mouse and keyboard, in terms of what kind of user input that you need to detect, it's usually these three things right here. So you've got keyboard button press. So like any keys on your keyboard, if they get pressed, you can make the script do something. Or same thing with the mouse button press. Or again, mouse click on game objects, which is the approach that we're going to do today. Now, each one of these scenarios will have their own code snippets for you to be able to copy to your own custom scripts, but I'll just go through them one by one. So if you want to be able to detect a keyboard button press on your script, it's just a matter of making use of the input.getKeyDown method, which is this one right here. Now, I'm not going to go through explaining what each of these lines of code mean, because that's what these inline comments are there for. So if you're not familiar with any of these methods or any of these lines of code, simply just have a read at the inline comments that I provided. So the way I've laid out the information, it should be easily understandable even for someone who's not that much of a guru with programming. So I have provided the slides that I'm using now as a PDF file in the week 5 tab in Milo. So definitely check that out later on if you want to quickly review what these code snippets are, or if you just want to copy them to your own custom script. One thing to keep in mind, though, is that you want to make sure that the input.getKeyDown method that you're using is inside the update method. The update method basically is getting called once per frame of the application. So basically, every time we're updating the frames of your application, because remember that we're just rendering multiple frames at a really fast rate to sort of get that illusion of smooth movement sort of thing, kind of like with animation. We're making sure to check for user input. So we need to make sure that that check is actually inside the update method. And yeah, you can copy this code if needed. Now, if you want to be able to detect a mouse button press, you just make use of the input.getMouse button down method instead. And again, that goes inside the update. One thing to make note of here, though, is that there's like these 3 different uses of the get mouse button down method, each with their own parameters. So you got like 0, 1, and 2. Now, these numbers correspond to the different buttons on your mouse. So 0 meaning left mouse button, 1 meaning right mouse, and then 2 meaning your middle mouse button. So what you want to detect will depend on, you know, what you're gonna end up using for this one. You don't have to use all of them. You're only gonna copy the specific sort of like code bracket that you're gonna end up using. And then lastly, if you want to be able to detect a mouse click on a game object, you're going to be making use of the on mouse down method. So this one goes outside of the update method, and that's because this method will only get called if the application actually detects a collision between the position of where the mouse cursor was when you're clicking on it and the sort of like the boundary of the game object. So that's going to be the collider of the game object. Now, something that you'll notice is that in FPS controller, right? So if I go back and play the application, you'll notice that the cursor is actually missing when you're playing the application. But turns out it's not really missing. It's just that the cursor is actually just hidden. And it's actually positioned at the dead center of your screen at all times. That is until you press escape, in which case your mouse cursor gets unlocked, and then you can start doing whatever with the mouse. Now, in our case, because we want to use on mouse down for our sort of like starting point for our interaction, we need to make sure that the game object that we're interacting with, which in this case is the radio, it has to be centered at our current camera view in order to actually initiate that interaction. Is there something like on mouse down, but if we want to use E for interact instead of mouse button? Actually, I don't think there is. So if you want to be able to use E, but you still want to do, you still want to detect the collision, rather, there isn't really, because like in that case, if you're using something like E, usually what you do is you check distances between like the game object and the sort of the avatar that you're actually controlling. Usually that's the way that it's set up. With on mouse down methods, like it's with stuff like like say RTS games, for example, and like you want to be able to tap on like game objects. I think that's the reason why this particular method is there to begin with, but not for like keyboard presses. So yeah, you're gonna have to do some custom system for that, but it's not that complicated really. And yeah, so you need your game object that you're going to attach the script to, which contains on mouse down, will need to have a collider component attached. So let's actually go ahead and go back to our project and attach a collider game object. So again, just selecting the radio here, go to your inspector window, add component, and I'm just going to look up collider. Now it can be any collider type. It doesn't really matter. So in my case, I'm just going to go ahead and use box collider. And I'm actually just going to resize that because it is a bit too large for my liking. Also just reposition the actual bounding box as well. And maybe make that a bit bigger on the x-axis. Yeah, something like that. That should do. All right. All right, and then that's it. So with all the components in place, we can actually go ahead and create that custom script as a starting point. So back in the project, if you just go ahead and go to your project view window, again at the bottom of your interface, and right-click on any empty portion of your project window, you can bring up the pop-up menu. So just go ahead and select Create, and then C# script. Now for this one, I'm just going to name it again, like play music on mouse press. And I'm actually going to put that in my scripts folder just to be organized. All right. And then before I open it up in my text editor, I'm just going to attach it to the game object first. So I'm actually going to attach it to the radio game object directly, which contains our audio source component right here. Yep. And again, you'll know you've attached it correctly if you drag and drop it to the inspector window while having the game object selected, because you can actually see that script component right there. So once that's attached, you can go ahead and double click on the script file to actually open it up in Visual Studio. Now, Visual Studio, you should have installed that while you were setting up your Unity in your personal machine back in week 1. If you're having any issues with Visual Studio at all, like you can't install it for some reason, or you're getting some weird errors when you're opening up a script, let me know on private chat later so that I can follow you up on that. Okay. So when you open up any new scripts in Unity, should be what you're seeing. So like this is basically a template of what you could potentially use for your project. You can just erase those if you don't need them. But in our case, I'm just going to go ahead and delete the update method because we're not going to need that. Again, we're using on mouse down, and then I'm just going to keep the start method right there. So again, in your case, if you're setting up an interaction, again, just go through some of these code snippets depending on what you're using. So again, I'm using on mouse down. So according to the screenshot, I just need to use the on mouse down method here on my script. So let's just go ahead and add that to my script now. So on mouse down. The good thing with Visual Studio as well is the autocomplete for stuff like Unity classes and methods. So that's one big advantage. One thing you need to be really careful of when you're creating your scripts is typos and also missing semicolons. Like you can pretty much ask a lot of programmers, and you'll find that most of the time they end up wasting is because they missed a semicolon or two, or they just misspelled like a class name or a property name or something. But that's just part of the programming life, I suppose. All right, so now that we've got the user input detection out the way, next thing we need to do is we need to be able to actually mess around with the component that we want to use. So in our case, the audio source. Now, in order to actually change a component's properties or call any of the available methods for that component, we do need to get a reference of that specific component in our script. Reason for that is because, unfortunately, the code that we write in Unity is really, really dumb. We need to specifically state what exact component within your scene your script will actually need to adjust. So say, for example, you have 5 game objects in your scene, and you're writing a script that instantly teleports one game object from one position to another, right? So you'll be using the transform component for that in your script to actually change the exact position of the game object from one point to another, right? Now, problem with that, though, is you have those 4 other game objects, right? And each of those game objects have their own transform component as well. So now you're starting to, with that, you're starting to see the reason why, the script needs to be specifically sort of told what exact component, because otherwise, it won't be able to know which exact component you want to change. Now, there's 2 scenarios that will usually happen when you're trying to get component references, and each scenario, those 2 scenarios will have their own sort of like code snippet that you can use. There's multiple ways of getting component references, but for the sake of simplicity, this is probably the easiest way to work around those 2 situations. So make sure that you, again, if you don't understand what the lines of code mean, you can just refer to the inline comments that I provided in the screenshots. Now, first situation, if you're trying to get a reference to a component that's attached to the same game object as your script, you can use this code snippet as a starting point. So basically, you just have a variable that stores your component reference. And then in the start method, which gets called when your object gets initialized, when the application starts up, you call the get component method, which basically handles getting that component reference and then storing that in your actual variable, like so. Now, again, with the screenshot here, so when I say component attached to the same game object as the script, it should look something like this. So you have a cube game object, for example, and again, the transform component that you want to mess around with, you should be able to find that along with the script component that you've attached in the inspector window. So this is the first situation visualized, and also this is the exact same situation with our current setup. So we've got the radio, which has the audio source, and the script file itself. So we can go ahead and copy this sort of code snippet here. So we just need that reference variable. Now, in the screenshot here, this is a type transform for the sake of the example, but because we're getting a reference to the audio source component, we just need to specify audio source type, and I'm just going to call it my audio source. Variable, again, variable names don't really matter. It just depends on your preference, whatever works for you, I suppose. Oh, another thing as well is that with the assignment, we're not really going to look into your coding style or like the efficiency of your code or the cleverness of your code. What we're more concerned about is your end results. So, if you have to do something really hammy for your prototype in order to get like some complex interaction or system working, go for it. As long as that doesn't actually cause you like compiler errors, in which case, yeah, you're in for a bit of a bad time. All right, and in the get component method call, just make sure that you're specifying the component type inside the angle brackets, like so. So again, we're getting audio source, so that should be audio source right there. All right. Now, that's the first situation. Second situation that you may come across when you're getting component references is the component is attached to a different game object from the script that you're currently using. So for this one, maybe your audio source, for example, is located in a different game object called sphere. And then in the cube, that's where your actual custom script is. If that's the sort of situation you're in, what you need to do is you need to use this particular code snippet. But really, the main difference between this one and the previous one is, in addition to the reference variable for your component, you also have a reference variable to the game object, which actually contains your component that you want to mess around with. So if you go back to the screenshot here, on the second screenshot below, under get component from different object script, you'll notice that there's this property box here called my game object, which corresponds to this public game object variable call that we made. So this is how we're actually going to get, this is how we're going to point to the script, what game object contains that component that we want to get a reference from. So you just simply drag in this case, the sphere, which contains our audio source, into the property box next to the my game object variable. And again, you'll know you've done it correctly because you've got sphere listed as the listed in the property box. And when the script starts, that should automatically get the component based on that game object reference right there. So again, just be really careful and make sure that you're using the right code snippet for whatever situation that you come across. It takes a bit of getting used to, unfortunately, but it's just something that you need to get better with over time because, like this is like a main part of the workflow of actually getting things to function in your scenes and game objects is to be able to get references to those components in order to actually call whatever method you need to sort of call in your interactions. Now, when you've actually fetched the component, so you have a reference to it, you can actually go ahead and use the reference variable in order to actually call whatever method or property you want to change. So first example, I just got a method call for play. Now, the play method is the method that actually plays the audio files that's linked to the audio source by the audio clip property. And then second screenshot here is just a call to the volume property. So you're changing the volume to 0.5F, which is equivalent to 50%. So that's just how you call properties or methods in your script. So with that, we can actually go back to our script. And inside the on mouse down, we can actually go ahead and do that same call. So my audio source dot and then play. And we just need to put this in and save. And now we should have everything set up in our script. However, if you actually start up the application now, and this is something that you won't hear because my audio isn't actually shared in the screen share. The audio actually plays immediately when you start up the application. And the reason for that is because if you have a look at the audio source component on the radio object, on one of the properties listed under audio source, you'll see that there's this thing called play on awake, and that is currently ticked. So that if it's ticked, that basically means that the audio will play every time the application starts, regardless of how you want it to set up. So simply untick that, and then save again. And now audio doesn't play at all during application startup. And if I actually go forward in front of the camera, in front of the radio, and make sure that that's centered, and then tap on my left mouse button, that actually plays the audio. Again, you can't hear that because that's not being shared in my screen share. But yeah, that's basically basic interaction down. So again, just getting that user detection, input detection set up, and also getting references to the component, and then calling whatever method or property you want changed based on whatever interaction you're trying to make. Now, probably one. Can you show the code page again? You can open up the, well, that's what the code looks like, by the way. You can have a look at the PDF as well on Milo if you want to double check the code snippets as well. Yeah, so you just got a private variable audio source. Then you've got a start method, and inside that start method, you have a get component call, which again is type audio source. And then inside the on mouse down method, you have a play call to the play method for that audio source component. So, really simple lines of code. Now, one of the main challenges with setting up these interactions is actually figuring out what properties or what methods are actually available when you're creating your own custom scripts. And this is actually where the API documentation comes in with Unity. So if you actually have, like a quick Google, so say, type in Unity API audio source, for example, the first result that you see should bring up this page right here. And basically, the API documentation pages for the components basically list stuff like descriptions of what the component actually is. Even has stuff like example code, so you can actually use the code inside there as reference to figure out how to actually use that particular component in your scripts. However, the main challenge with looking at these API documentations is that a lot of the time you're going to be experiencing quite a bit of information overload because not everything is going to be relevant for the particular use case that you're looking to set up. So usually it's a good idea to learn the skills for being able to look at the exact specific kind of information that you want to have a look at. So if you do something like a Control F and then just use whatever keywords it is that's related to the kind of interaction that you're setting up, that's usually a good start. Sometimes the information that you're looking for might just be in the description. So for this audio source example, if you actually wanted to know what method actually does the playing of the audio file from the component, you can see that in the description here, it says that you can play a single audio clip using play, pause, and stop methods. And if you actually click on any of these links, that should bring you to a details page of the what was it, like the whatever method or component, method or property you linked, and that just shows you again stuff like descriptions or example code, which is really nice. Now, usually good sections to look out for are the properties and public methods section of the page. So that's where most of the properties inside that you can find in the inspector are actually listed. So you can see that there's stuff like loop and clip. So clip is corresponding to the audio clip property at the top. And also you got the methods as well. So there's play. So when in doubt, have a look at those two sections of the manual page first, and then go from there. Now, of course, there are also bound to be alternative resources online as well that will cover how to use specific components or how to set up, specific interactions. Now, in one of the videos, for example, that I had in the resources tab in the web page, there are videos that show you how to do stuff like, grabbing game objects or how to animate, like door openings and whatever. And, relying on those information is fine as well. Like one of the best things with Unity is like the community that's revolving around it. The community has done a really good job of setting up like information sort of like databases or like tutorials of how to use like commonly used tools and components in the engine. So if you have to rely on those, and usually they're a bit easier to digest as well, I'd say definitely go for it. And I actually have a link to some of those videos in the webpage that I'll show later. So our assignment only involves simple code. Yes, usually. So again, with the assignment, when you're only looking for at least one, you can definitely go with more complex interactions. So like, multiple system layered on top of one another in order to achieve like some sort of complex effect or something. It really depends on how far you want to go. We can definitely see, like people going that extra mile get, extra credit for their assignment. But, for the sake of passing this particular assignment, you don't have to go too ham. Really, as long as you can sort of communicate, the main idea behind your prototype, whether that's your design or your one active interaction. If that's enough, then I don't see any problems whatsoever. All right, now some extra points before I close off. Now these are like some general guidelines that you might not necessarily think about in your prototype development, but it's something that you need to be aware of for VR development in general. First is movement in VR. Now, with a lot of VR applications, usually they don't use conventional movement mechanics. And what I mean by that is like that smooth, constant movement in one direction when you actually hold down a button on your keyboard, for example. So just this one, like just again demonstrating. So this is what I mean by having that conventional movement mechanic. So just just a smooth transition from one position to another while you're holding down the key, right? With maybe a bit of a head bob here and there to simulate that sort of physical, presence in the scene. Now, usually other sort of VR apps don't use that. And the reason for that is because to sort of minimize virtual reality sickness. Now, this is an issue that's been plaguing, VR apps for quite a while, and there's a lot of resources about this, but generally a basic gist of it is that the conflicting information between what the eye sees and what the body actually feels. So you have a VR headset strapped to your face and you're moving around with your controller, so you're using like the joystick to move forward smoothly, but and that's what your eye is seeing, right? So you're moving forward smoothly in one direction, but because your body doesn't actually feel like it's sort of moving, and also it has something to do with like your balancing as well. I can't really get into the specifics of it without wasting so much time. The conflict between what the eye sees and what the body feels sort of triggers that sort of sickness, and that has like a lot of effects. So stuff like nausea, like vertigo-like effects, for example. And if you're trying to develop like a user experience in VR, you want to minimize that as much as possible, which is why Like people come up with these multiple movement setups for their applications. So usually the most common movement options that we're seeing is stuff like teleporting from one point to another. So, like because you're instantly moving to that specific point without, having to experience that smooth transition, right? You don't necessarily feel like you're moving at all, like you're just quickly swapping, and it doesn't trigger that conflict between, like what the eye sees and what the body feels. And that just sort of helps alleviate, prevent that sickness from actually triggering. And also, same thing with the camera rotation as well. So if you play a VR app, if you actually use the right stick to move your camera, you'll notice that instead of smoothly rotating in one direction, it's actually snapping at specific angles. And again, it's the same logic behind that. So you're trying to make it so that the user doesn't see that smooth movement to avoid triggering that sickness from the conflict as well. And sometimes developers even go as far as to designing their experiences to revolve around like an avatar that doesn't move at all, so a static avatar. So that's another way that people have done to sort of avoid triggering that. Now, whether or not you consider this in your VR app, again, it really depends on you. It's not something that we'll consider in the prototype because you're mainly, you're using just an FPS controller, which just uses mouse and keyboard, and you're not going to come across that issue. But again, it's just something like that you need to be aware of for VR development, because this is one of those challenges that we have to face when we're making this sort of thing. Next, you've got interfaces in VR as well. So traditional heads-up displays aren't really used in VR applications. So when I say heads-up display, so this is like any interface elements that are present on your screen at all times, regardless of where you look. So going back to that CreatorKit FPS example, so you got stuff like the map or like the timer or the points or, like gun information, so text, images and whatnot that always stays on your screen, regardless of where your camera is looking. So that's pretty much what a heads-up display is. And also that's an example of screen space interface in Unity. So screen space meaning it occupies the actual sort of the screen dimension, so to speak. And if you actually develop a VR app in Unity while you have a screen space interface, that won't actually render in your headset view. So you're still sort of incurring that rendering cost for setting up that HUD, but you're not getting the benefit of it because you're not seeing it from your headset at all. And also, it's not a good idea as well because, like, generally with VR apps, you want the view from the headset to be as clear as possible without any obstructions. And basically, you're going to do the opposite when you introduce a HUD for your user. Now, if you want interface elements like text or images in your app for any reason whatsoever, usually it's better to set them up in world space instead. So what that means is that they're actually, the interface stuff is actually a part of your world rather than like being a separate sort of element residing on your screen. So going back here, in this screenshot to just sort of demonstrate the concept. So the various windows here are actually residing in some 3D point, some point in space. And if you actually move your camera angle around, you'll see that they're actually fairly flat because, well, they're plane. And yeah, by doing it that way, you avoid that conundrum of blocking the view from the headset by having to add these extra elements. If you played something like, if you played games like Dead Space, for example, like, you sort of get the idea because like that was one of the earlier sort of clever implementations of World Space UI, which is really neat. Also, I just love that game very much. But yeah, I think Division also had this sort of implementation as well in their UI. I don't know if anyone here plays Division though, or Dead Space, but yeah. Also, last thing, application performance. So another stat to keep track of for VR applications is frames per second, and this is really important. If you're not familiar, frames per second is basically the amount of frames drawn within a second. So your applications is basically a sequence of frames drawn together at a pretty sort of fast rate. And basically, the more frames that you have per second, the smoother your viewing experience will be. Emphasis on the viewing experience, because if your user is experiencing a lot of stuttering while they're having a look at your virtual environment with their headset strapped on, again, that's going to be another sort of vector for sickness, for that virtual reality sickness that I touched on earlier. Now, generally, it's a bit of a complicated topic in terms of like performance optimization, but general rule is if you have a lot of game objects with detailed 3D models, and if you have a lot of complex scripts as well, that take up quite a bit of CPU overhead to actually sort of maintain, then that will affect your FPS numbers by decreasing the amount of frames that can be drawn in a second. Now, ideally, when you're developing a VR application, your FPS numbers should actually match the VR headset's refresh rate. Now, refresh rate is it's almost the same, but it's a bit different. So it applies for your displays. Basically, it's the number of times a display updates with new frames. So it's tied to the hardware rather than the application. If you're curious, the Oculus Quest has a 72 Hertz refresh rate, and the Oculus Rift S has an 80 Hertz refresh rate. Now, if you're curious and you actually want to see how much FPS you're getting with your application, you can actually open the stats display on the game view, as seen here in the screenshot, and you should be able to see your estimated FPS numbers on your scene. So according to the screenshot, for example, I actually had like 718 FPS, which is quite a lot. If you go over the refresh rate of your display, it doesn't really matter. It's only when you go under and you start noticing that stuttering, which could affect the viewing experience, that's where you want to be really worried. So again, not something to worry about with your prototype, because again, you're making fairly basic stuff, but this is, again, one of those quintessential concepts that you need to sort of start grappling with when you're creating those VR dev VR apps. All right, so that was quite a bit of content. Apologize for that. All right, so hopefully with that demo, you could actually have a go at implementing your own active interaction on your current VR project. So remember that the requirement for the assignment is you need to have at least one active interaction in your app that addresses the limitations or the problems given the project scenario that you're running with. So what I have here are some resources, actually, that you can use to help you out to figure out, how do you want to sort of write the scripts for this specific scenario you have in mind. Probably the most interesting here is the first two links. So first one is a video tutorial that shows you how to set up like a grabbing mechanic. So if I actually play my prototype again, I've actually gone ahead and implemented this real quick just so that I can show you. So if you go in front of a barrel here and hold down your mouse button, if I actually implemented that in my thing, actually I didn't. That's why. It's because, right, it's because I replaced the, sorry, a bit of a hold up. And then, because like I deleted the FPS controller avatar yesterday. There we go. Yeah, there we go. So like that's basically what it looks like. So you can just go in front of an object, you can hold down your mouse to sort of grab the object with you. And then if you just let go of the mouse button, that just releases it back to the world. So that video will actually show you how to set that up. So if, when in doubt, this is a good starting point with learning how to do some custom coding. Second link shows you how to set up like a door opening animation. And this actually is a good introduction as well to the animator component. So if you have art assets that have 3D animations, that will actually show you how to create an animator controller and how to set up the different animation states and call them in your script, which is really handy if you want to do something fancy with animations. So definitely have a look at that as well. And also, I've just got some manual pages to the commonly used components. So again, stuff like audio source or animator, colliders, and whatnot. So definitely check that out as well. And yeah, that is pretty much it from me. So I will leave you guys to it. Again, you guys know the drill. If you need any help, just let me know and I'll follow up with you as soon as I can. All right. Yo, what's up?
I would mind like discussing some of my project if you have a free moment.
Sure, no worries. I forgot to set up a breakout room. Let me just do that and I'll
That's
move
all
you
good.
down. Someone's raising their hand. Before I address that though, sorry, I forgot how to add a flat. I'm assuming you mean plane. Let me just activate my screen share again real quick. But basically, there should be like an option under 3D object in the create menu for a plane. But just to show you, yep. So if you just right click on like your empty part of your hierarchy window on the left, that should bring up your create menu. So you just need to hover over 3D object and you should be able to find plane right here, which is this one. And then you can start moving it around and then resizing it depending on your preference. All right, who is raising their hand? Shoot, let me know what's up.
Can you make a room? Because I have a big discussion.
Sorry?
I want to have some discussion. Can you make a room?
Oh, okay. Yeah, I'll put you down in
Thank
the
you.
break room.
Thank you.
Yep, I'm back. Sorry about that. Someone's raising their hand. Wanted to ask a question. Hello? I heard static and then just silence.
Hello. I want to share my screen.
Okay. I'll put you down in the screen share. Tanvir, I'm gonna get back to you in a bit. Sorry, man. uh, I'll let you know when I'm finished with this one. All right, so we got about 6 minutes remaining. This is a bit worrying because I still need to show like one more thing. Like it's something fairly minor for now, but something that might catch your interest if you're interested in using the VR hardware for your future VR assignments, maybe. All right. So you probably noticed that in the week 5 VR tab, there's actually an extra web page in there called Quest with Unity. And basically, that web page contains like the steps that will let you quickly add VR support for like an empty sort of like a brand new project. Now, the content in here is mostly stuff we've already covered last week. So stuff like stuff like the avatar prefabs, like the OVR camera rig and the OVR player controller, for example. But this is a more detailed step-by-step instruction that tells you, how to how to import the Oculus package into your Unity project, how to create a simple VR scene with the avatar prefab present, and how to set up like the various project settings so that your project is actually compatible for the Oculus Quest platform. So Oculus Quest is actually running on a custom Android OS. So you just have to make sure that your project is built for the Android platform. This is why we asked you to actually install those Android modules if you're interested in building a VR app for the Oculus Quest. And also the last step covers how to create a simple build and deploying that to your Oculus Quest as well. So which is really nice. But what I wanted to show you guys was what was it? Like some of the interesting scenes here in the Oculus Rift, but unfortunately, I don't think I have enough time left for that. Now, with VR development, right? Like I mentioned before, you can easily put in, like a VR avatar prefab into your scene, and like as long as your avatar can move around in your visual environment and your interactions still work with your avatar prefab, then you're pretty much golden. But if you want to take advantage of the extra features that come with using the VR hardware, what might interest you are some of the demo sample scenes available in the package. So say, for example, if I go to sample framework and then go to core. Now, core is basically like usage rather. So if you go to Oculus and then sample framework and then usage, so this is when you've actually imported the Oculus integration package into your project. So you need to, again, you need to go through the asset store to do that. Now there's stuff like here, like say, for example, distance grab. And that will actually show you a sample scene where you can actually grab the various objects, in the environment, either, up close or from a distance. And the main point of these sample scenes is so that you could actually have a look at the hierarchy setups, as well as the components, as well as the scripts that were used in order to actually make those interactions work. Because the thing is, if you want to take advantage of the hardware, you need to be able to sort of understand like how the API works, how the custom classes and structures work, and you need to know, what sort of methods or properties you need to call for those specific interactions to happen. Now, Oculus does have a Oculus API documentation page available, which you can have a look at. So this goes from stuff like, basic setup from the Oculus Quest all the way to, again, references to the SDKs and the tools, as well as the packages. What you're looking for here is the scripting reference tab. And that should give you a link to the actual documentation that lists all of the available classes, along with the, stuff like properties and events and all that sort of programming stuff. Now, again, this is something that you don't really have to do for your VR assignment. This will mostly just apply if you want to actually make use of the VR hardware, either loaning it from the HitLab or using your own VR headset. But keep in mind, though, that that only applies if you have an Oculus headset. If you have something like a Valve Index, development for that particular device is going to differ a lot, because it's going to be using its own set of tools, as well as, like SDKs and whatnot. And, officially we only support Oculus for this one. Another thing as well is that you need to install the Oculus software in your machine, which is this one right here. So this software just manages stuff like, like your devices, updates, firmwares, and all sorts of other goodies. So like your game libraries and stuff. That needs to be active so that you could actually, so that your machine can actually recognize the headset that you plug into it, and then assign the appropriate drivers so that your setup will work when you run your application. And you should be able to find the download link to that software if you just Google up, Oculus software, Windows or something. But yeah, definitely refer to, like, if you want to get started with, like Quest development in Unity, definitely consult this document. And if you have any questions regarding, where to get started with the API, if you want to start learning, for example, you can definitely ask me, either anytime or via email, and I can point you towards like a general direction, depending on what you actually want to do with the hardware. I've mostly worked on the Rift S, because my previous contract work was mainly involved with the first revision model, as well as the Rift S itself. But for the most part, development between the Rift S and the Quest is similar, because they're using the same APIs. It's just that when you're building your project, you have to sort of like specifically state in the build tools that you're building for the Oculus Quest rather than the Rift S. All right. I'll put my email on global chat, by the way. I mean, you can look me up in the email directory, but for your convenience, it's right there. All right, so we're already 2 minutes over. So I'll let you guys be. If you have any more questions, let me know in the private chat. Otherwise, I will catch up with you guys next week. So yeah, enjoy the rest of your week, and yeah, good luck with your assignment progression, and hopefully things go smoothly. Catch you later, guys. I need a drink. Yep, later. Cheers for the drink. I'm referring to water, my friend. A bit too early for some fun stuff.